Right, so today we're going to verify a couple trig identities using sum and difference things. So we're going to start with this one right here. And again, we need to make both sides look the same, but we can't treat it like an equation because we don't know if it's equal. So for this, I'm going to change the top on the left using our property number 9. Cosine alpha minus beta becomes cosine alpha cosine beta plus sine alpha sine beta all over sine alpha sine beta, and I want that to equal cotangent alpha cotangent beta plus 1. Now, I know we've often talked about our first thing is to get everything in terms of sines and cosines, and that might be helpful, but for now, until I get a little farther in, I'm going to leave this the way it is, because I kind of see cosines over sines, which is cotangents. So I don't know that I want to necessarily change the other yet. For me, I see on the right side, I have two separate things. And on the left side, I have one fraction, but it's a fraction that has a plus on the top. So we can do what we call breaking the heart, where I take this one fraction with a plus on top and I can split it into two fractions with the same denominator. Because essentially this could have come from two fractions, each having a sine alpha, sine beta on bottom, right? And this one would be sine alpha, sine beta. This top would have been cosine alpha, cosine beta. And this side is sine alpha. That's supposed to be an alpha, sine beta. And this is where I guess I could, if I switch this side over here to sines and cosines, I get cosine alpha over cosine over sine alpha. Try that again. I do know what cotangent is. And then cosine beta over sine beta plus 1. And now I am super close because this right here, that's a 1, that's a 1, 1 times 1 is 1. And so I could write it like this, or I could even go back and say this is my cotangent alpha, cotangent beta plus 1, and we get the same thing on the other side. See, I think I was right in my first thing and not switching over. And we've proven our identity. Okay, we can also do ones that involve some trig exact values because we are always trying to recall and refresh our trig exact values. So again, cosine alpha minus beta, that's what this one is like, where this is my alpha and this is my beta. So I can use identity number 9 and say this side on the left turns into cosine of the first thing, cosine of the second thing, which in this case is theta, and then plus sine of that first angle, which is pi over 2, and then sine of the second angle. Oops, theta. I'm not doing beta, I'm doing theta. And all that should equal sine of theta. Will that be true? So here's where you have to do some trig exact values. I know that cosine of pi over 2, because it's the x coordinate at the very top of my circle, that is 0. And 0 times cosine theta is just 0. Sine of pi over 2 is 1. Because again, at the very top, my y value is 1. And at the end of the day, I am left with sine of theta equals sine of theta. I work each side, I use my properties and my identities and algebra and arithmetic and my trig exact values to simplify. And I have now verified that cosine of pi over 2 minus theta equals sine theta.